Today we're going to focus on writing inequalities and also representing the solutions on number lines. This is Chapter 8, Lesson 6. We need to be on page 643. So this first page we need to take notes, and this is kind of a reminder about the fact that inequalities have infinite numbers of solutions. So we're going to look at these situations, and we've already circled the numbers for you, so you will need to copy this down. So for number 1, Jessica spent more than $5 at the arcade. She didn't spend $5, so that is not circled. She spent more than $5. And so it could have been 6, 7, 8, 9, 10, could have been 21, could have been 30, could have been 100. $1 million is probably excessive, but still that's one of the possible solutions. It goes on infinitely forever. So anything greater than 5 is a possible solution, but not 5. So for number 2, less than 6 people rang the bell on the mallet game. 6 people did not ring the bell, but 5 did, 4 could have, 3 could have, 1 could have, 0 could have. -1, -2, all those negative numbers are not possible, but I guess theoretically, I don't know, infinitely, sure. But these are definitely some possible solutions here, but not 6 or anything greater than 6. So the inequality for this would be less than 6 people rang the bell. Okay. Number 3, there were less than 10 people in line at the Ferris wheel. So there weren't 10 people, so we're not going to circle that. But anything that's less than that is going to be a possible answer, including the number 0. Again, negative numbers, unlikely. It costs more than 6 tokens to ride the bumper cars. So it doesn't cost 6, so that's not circled, but anything greater than that is going to be something that could be an answer for how much it takes to ride the bumper cars. So not 6, not 5, nothing like that. Anything greater than 6 is going to be a correct answer. And again, going on infinitely in the positive direction. There are less than 8 lemonade stands. So there are not 8. So it's not circled, but there could be 7, 6, 5, 4. It could be 0. Again, negative numbers probably not correct, but these are all the possible answers that could be correct. So finally, there are more than 12 different flavors of taffy. So there aren't 12, but there could be 13, 14, 15, and so on, going on infinitely in the positive direction. Now, what pattern do we see for this? If you're using simple less than or greater than, it will not be the actual number that you're comparing it to. It's not going to be one of the possibilities, but you're going to circle whatever's on the right if it's greater than, or whatever's on the left if it's less than. So that's a pattern you need to have noticed. The first skill we're going to focus on is writing inequalities. So you can write an inequality to represent the constraints or conditions within a real-world problem. To do so, you have to define your variable first. So it's very much like writing an equation. To write an inequality for each constraint or condition. So you must be over 12 years old to ride the go-karts. So age is important. Over 12, that does not include 12-year-old people. You have to be 13 or older. So if that was the case, it would have said you have to be at least 12 years old, but that's not right. 12-year-olds cannot ride go-karts. They've said A for age is the variable, so your age has to be greater than 12, and that does not include the number 12. Now, the next one is for something to be called a pony, it has to be less than 14 2/10 hands tall. So ponies have to be less than this amount. P for pony is going to be representing the height of the pony. So in order for something to be a pony, it has to be less than 14 2/10 tall, hands tall. 14 2/10 is not going to be a pony because it doesn't have the equal to sign. So this is going to be the inequality. You must be at least 16 years old to have a driver's license. So this one's a little bit different because the age is at least 16 years old. that means that 16-year-olds can have a driver's license. So if A is equal to age again, this time the age of someone with a driver's license has to be greater than or equal to 16. So that's going to be the symbol we use for that. Okay, so let's go ahead and try one of these on our own. For the first practice problem, we're going to write an inequality for each constraint or condition. It says you must be older than 13 to play in the basketball league. So my first question is that going to include 13-year-olds, yes or no? The answer is no, so that's not going to be an and equal to situation. So the second thing we have to do is pick a variable. So what variable should we use to represent a player in the basketball league? Go ahead and answer that. Any letter will work. Okay, so I chose B, but you could have chosen P for players, so I chose B for basketball. So we're going to compare 13 and B. So the next question is going to be, does 13 going to be less than the age of a basketball player? Is 13 greater than the age of a basketball player? We know it's not going to be equal to, we know it's not going to be greater than or equal to or less than or equal to. So pick which one it's going to be. Go ahead and do that for me. Okay, 13 is less than the age of the basketball players. And you could have flipped it around and said basketball players have to be greater than 13. If you want to switch them around, that's fine. Okay, let's try another one. To use one stamp, your domestic letter must weigh under 3 5/10 ounces. So what's the variable that we're going to use to start with to describe our stamps? Go ahead and pick a letter. All right, I chose S for stamp, and so it's whichever one, or you could have chosen D for domestic letter or L for letter, whichever one's fine. Must be under 3 5/10. So does that include 3 5/10 as a possibility? Yes or no? It's going to be no. It has to be under that amount. So if it weighs 3 5/10, it's going to be more than one stamp. So are we going to use the less than symbol here or the greater than symbol? Go ahead and answer that for me. Okay, so once again, the stamp is going to have to be less than 3 5/10 ounces. Of course, if you wrote it the other way and said 3 5/10 ounces is greater than one of the stamps, that's fine too. So as long as you have the symbol switched, then you would have the label switched. So please understand that. Okay, finally, you must be at least 18 years old to vote. Okay, so we're going to be thinking about the number 18, and we're going to pick a variable first, though. So what variable should we use to describe that you have to be 18 years old at least to vote? Go ahead and pick a letter for me, please. Okay, I'm going to go with V for voters, but really any letter would work. Now, should a voter be greater than 18, less than 18, greater than and equal to 13, or less than and equal 13? Go ahead and answer that for me, please. Okay, this is a little bit like the driver's license question we answered earlier. You can be older than 18, like way older than 18 and vote any number up until the very end. So you could have a 110-year-old voter. That's a possibility. But you cannot have anyone voting who's less than 18. But if you are 18, you can vote. So that's why we have to have the equal to sign. Okay, so now we're going to talk about how we would represent these on a number line. Since there's more than one answer, it's not going to just be one dot. We're going to talk about how we draw those on a number line. Okay, representing an inequality on a number line. Inequalities can be represented or graphed on a number line. Sometimes it is impossible to show all the values that make an inequality true. The graph helps you see the values that make an inequality true. Okay. So here's some examples that they have done for us. Represent each inequality on a number line. So if n is greater than 9, if you come over here and look at the number line, do we notice how there is an open circle here? The open dot means the number 9 is not a possible solution. So go back and think about to the first page of our notes today. It has to be greater than 9. It's not equal to 9. So 9 is not a solution, but this is called a boundary point. So everything after the 9 that's greater than 9 are all possibilities, and they go on infinitely. So you show that by drawing a dark shaded line going to the right. So any of this stuff to the left is not a solution, and 9 is also not a solution. Okay, so that is how we graph the n is greater than 9 on a number line. What about the inequality n is less than or equal to 10? So we have the equal to 10 part. So if you come over here to the graph, you'll notice the 10 has a dark shaded dot. Now this boundary point is closed. It is filled in. So that means that 10 is a possible solution. It could be equal to 10. But then everything else that is less than 10 is also a possible solution. And that's why we have shaded in everything going to the left infinitely, even into the negative numbers. All of these are possible answers, but nothing that is larger than 10 is a possible answer. So it's infinite numbers could be the solution, but not every possible number is a solution. Not every number there is as a solution. Okay, so we're going to go ahead and do some practicing as well. So hang on a second. Okay, for D, it says that A is less than 15. So my first question to you is, what kind of dot should we make? Should 15 be an open circle showing that it's not a possible solution, or should it be a closed circle showing that it is a possible solution? Answer that for me now. The answers have to be less than 15. So that is not a possible solution, so we should show an open circle. Now, are the solutions for A, are we going to shade in everything that is to the left of the 15 or to the right of the 15? Go ahead and shade that in for me now. Okay, so because A is less than 15, we should have shaded everything on the left side where the lesser values are, and that's going to go on infinitely. Okay, so let's try the next one here. So if B is greater than or equal to 7, should the boundary point for 7 be an open or closed line? Go ahead and answer that open or closed circle. Go ahead and answer that for me, please. 7's a possible answer because it says or equal to, so that should be a closed boundary point. Now, the next question we have is, are we going to do a shaded line on the left side of that point or on the right side of the point? Go ahead and answer that for me, please. Okay, so the right side of the closed boundary point should be the shaded line because all of the values have to be either equal to 7 or greater than 7. So B is equal to or greater than 7. All right, so that's kind of the gist of what we're doing today. Please make sure you go ahead and give a thoughtful answer for what do you think the most important thing to remember from today is, and please look back at your notes if you need to. If you are panicking and can't think of anything right now, just go back and read through some stuff and figure out one thing that you can share that you think is important. Go ahead and answer that. Thank you. Okay, thank you for your thoughtful answer, and make sure you go back and to the lessons and make sure you've completed all your notes, any independent practice. You also need to make sure you are practicing your vocabulary words and you're working on your Imagine Math. Thank you.